Elon Musk just unveiled SpaceX's new incredible 3D printers. The printers enable additive manufacturing, often known as 3D printing, to produce rockets. It's the process of turning a computer file into a three-dimensional physical object, and Elon Musk is pushing it to unimaginable heights, as Elon is the first to develop rockets through 3D printing. How does it work? And can you really print a rocket and fly it to Mars? Welcome to Futured, your daily dose of tech content. Today, we will talk about how Elon Musk's new 3D printed spacecraft. So before getting into it, make sure to like, comment, share, and subscribe to our channel. Let's get started. I bet if you aren't familiar with 3D printing, you would think, huh? I'm not sure how that's possible. Let us jump in. SpaceX, a pioneer in technology. SpaceX is the first to create 3D printed spacecraft, according to Elon Musk. It seems like you won't have to wait for rockets to be made, since anybody with a 3D printer can now create a rocket, complete with components, engine, and body. But doesn't a rocket that can be created using a 3D printer seem crazy? Yes, absolutely. It sounds possibly insane, if not ambitious. However, 4 commercial clients have enrolled for missions to Earth orbit starting in early 2022, drawing inspiration from this. SpaceX, Elon Musk's privately held commercial space firm that aims to bring people to Mars, has released its crew-capable spacecraft Crew Demo on one of its first demonstration missions. What makes it even more intriguing is that it was 3D printed. As per Elon Musk, 3D printing is employed in the Dragon spacecraft's Super Draco thruster engine and one Falcon 9 rocket's engine. The Super Draco thruster engine is a more powerful version of the existing Draco thruster engine that SpaceX uses to control their Dragon spacecraft throughout orbit and re-entry. Moreover, Super Dracos will be employed on the first-generation Dragon version 2 spacecraft's crewed form. It will provide power to the vehicle's liftoff escape system, entirely incorporated into the spacecraft. Elon Musk has changed space travel, space colonization, and the economy in low Earth orbit and beyond. General Terence O'Shaughnessy even claimed that Elon Musk's SpaceX may have radically altered the capacity to identify threats to the United States through satellite clusters in orbit. In May, the general stated, "Holy smokes, talk about being able to move the ball!" Yes, he did mention that regarding SpaceX's launch of 60 tiny satellites at once. With his initiatives, Elon genuinely stunned everyone, even the general. But jokes aside, Musk has been exploring 3D printing for about 3 years. Last year, utilizing a direct metal laser sintering DMLS, SpaceX deconstructed the Super Draco engine chamber, which was 3D printed from Inconel, a high-performance super alloy. On the other hand, this part was totally planned and produced in-house. Furthermore, the business has successfully ignited the engine chambers to maximum thrust, 16,000 pounds per engine. However, SpaceX is already testing these engines as part of its rudimentary spaceflight program. And compared to conventional machining, 3D printing cut lead time by massively compared to traditional machining, and allowed SpaceX to go from first concept to first hot fire test in a little over 3 months. Last May, SpaceX completed certification testing for the Super Draco, which included repeated starts, extended firing durations, and significant flow and temperature deviations from normal. If required, the Super Draco may be restarted many times. Furthermore, astronauts can use the deep throttle, which is very strong and provides them with a high level of accuracy. Elon Musk claimed that the Super Draco engine was shot in 2 separate profiles during the fire test. Escape and landing burns were throttled between 20 and 100% during launch. During the intense fire, the chamber was shot more than 80 times. As part of NASA's Commercial Crew program, SpaceX executed this test flight without even a crew on board to show its capabilities to safely and reliably carry humans to or from the International Space Station. The Crew Dragon, on the other hand, was designed from the start to be one of the safest human space vehicles ever built, and it benefits from the current iteration of Dragon's flight heritage, which restored the U.S. capability to supply and return considerable quantities of cargo to and from the International Space Station. The Dragon has completed 16 journeys to and from the orbiting laboratory supporting human space research. It also has an environmental control system and a control and life support system to ensure that crew members are comfortable and safe. In addition, the spacecraft has a highly reliable launch escape mechanism that can safely carry the crew to safety at any moment during the ascent or in the rare case of an incident. Draco engines power the system on top of the launch pad, some of the first rocket engines manufactured entirely from 3D models. If required, the crew may assume manual control of the spacecraft. After leaving port from the space station and re-entering Earth's atmosphere, the Crew Dragon missions will dock and undock independently with the International Space Station. The crew of the Dragon will land in the Atlantic Ocean using an improved parachute system. On the other hand, Crew Dragon will deliver around 400 pounds of crew equipment and supplies to the International Space Station on its initial test mission. The spacecraft will also include mass simulators and an anthropomorphic test device, or ATD, equipped with sensors around the head, neck, and spine, and collect data before SpaceX's second demonstration trip with NASA astronauts on board. The journey from Earth to Mars takes around 150 and 300 days for the spacecraft. The speed of the launch, the alignment of Earth and Mars, as well as how much fuel you're prepared to and able to burn are all variables to consider. Despite this, with each rocket launch, 3D printed engine and orbital shuttle mission, the scientists and engineers at SpaceX bring it closer to achieving. Perhaps as the years pass, it all sounds a little too rosy. And there were a few obstacles along the road for SpaceX. However, the company's constant flow of NASA contracts forces it to do some real research and develop some out-of-this-world ideas. In 2014, SpaceX produced a Falcon 9 rocket with a 3D printed primary oxidizer valve, MOV, in one of the 9 Merlin 1D engines. And according to the business, the flight was the first time that SpaceX has flown a 3D printed item successfully. With the valve successfully working with high-pressure liquid oxygen at cryogenic temperatures and considerable vibration. The company's Super Draco thrusters are evidence of how SpaceX has been working with 3D printing. They were produced entirely in 3D. The Dragon spacecraft launch escape mechanism was powered by this engine, which enabled the ship to land with pinpoint precision on Earth and maybe another planet in the future. It was, however, made using direct metal laser sintering DMLS powder bed fusion technology. The chamber was cooled by regenerative cooling and printed in Inconel, a high-performance superalloy with exceptional strength and toughness for enhanced dependability. These rocket engines are projected to create enough energy to explode a ton of TNT per second, sending that energy into exhaust with temperatures well over 3,000 degrees Celsius. It needs engines that can accomplish this without dismantling themselves in an unplanned manner. Engineered from the ground up, it took at least 3 years. The repetitive process of redesign, rebuild, refire, and repeat consumes most of it. That's because rocket engines are quite complicated, but this isn't the first spacecraft made using a 3D printer. Aerojet Rocketdyne construction and hot firing is also a 3D printed rocket engine, as are NASA's 3D printed rocket injectors outperform welded injectors. This is significant for private space businesses. However, manufacturing a rocket isn't cheap, and as the Rudd scrap heap grows, investors may get jittery. When a corporation needs to postpone a launch due to its rocket's issues, its reputation suffers. 3D metal printing is practically all new rocket businesses and space entrepreneurs. Consequently, they'll make it through the key years before being ready to launch anything into space. SpaceX is proving to the rest of the globe that they are on their way to accomplish their goal. Their ultimate objective is to go into space, or more accurately, to travel between planets. They are prepared to go to any extent, or in this case, the whole planet, to put it into action. All the while, they're setting a precedent for the rest of the globe and keeping their counterparts on their toes. As some would say, a small step for SpaceX and a giant step for construction 3D printing. What are your thoughts on 3D printers? And do you think Elon Musk will achieve his goals? Let us know in the comments section below. If you enjoyed the video, don't forget to subscribe to our channel to never miss a video from us. That's it for today's video. Thank you for watching.